So now we move on to game theory. But this week we will only go through the basic concept and the Nash equilibrium part. And the rest we will do within the next 2 weeks. Let's go. Now, if you think about our daily life, there's a lot of cooperative situation in which we work together to achieve a joint outcome, right? This can be like when you play music in a band or for a concert with others, when you work together to solve the assignment in group, right? And life is so easy with this situation. Why? Because what is the best for the group will also be the best for its group members, right? You know exactly what is the best choice, what is the best decision to do. If you play music, play your part at your best. If you solve the assignment, try your best with your part. Now, I hope at least that's the case for the assignment. If not, I don't want to hear. Okay? All right. Unfortunately, at least to me, it's unfortunate. In life, we have also quite some non cooperative situation. What is that then? So, that's also called a strategic setting, in which everyone may have different objective, different expected outcomes, maybe conflicting to each other, which make it not obvious what is the best choice to do, because the outcome for you or the result, the consequence for you, will depend also on the action that the other want to take according to their interest. And this interaction of action will make the outcome uncertain to each partner. Okay. Fortunately, we have a theory which could be used to analyze this situation and predict the outcome of the interaction. It's called game theory. And I'm pretty sure that you have heard that at least one in your previous education. For me, it was in introductory macroeconomic course. So the task of analyzing a strategic situation, including two parts. So the first part is to tear down the situation into a simple game or model, which only several main elements and unnecessary detail already taken out now. So this is what we said about in the introductory week of our course, that we need some simple model in order to learn something, right? The second task is, having done the simplification, we could now solve the game, the model, in order to predict what will happen when individuals interact with each other on the rational setup. Now game theory is actually applied very widely in different fields like political science, national defense, or sport, right? For example, when you play chess with each other. However, here we will focus on economic set up. So a game is a way to call a simplified or abstract model of a strategic situation. Like I decide how much the market price or the quantity of pho I should sell, given my competitor next door who's selling pizza, or you decide how much effort you should put into maintaining a common area in your flat, for example. So a game will have three main elements. These are the elements we would have to pick or to identify from a strategic situation in order to apply game theories. They include players, strategies, and payoffs. The first element of the game is player. So who are playing? Who makes the decision in this situation? So because there are many strategic situations, like I said, in many fields, so the player can be individuals, firms, or countries, any unit of decision making in the situation that we're interested. For example, if I compete with the pizza place next door, then the pho business is one player and the pizza business is another player. If I'm thinking about cleaning or maintaining common area in my dormitory, then I'm a player. Other tenants in the dormitories are other players. So it can be two players, bilateral or multilateral, like in a free trade agreement among several countries. Then each of these countries consider one player, right? And these players, of course, have the possibility to choose among a set of course of actions to play, right? And these actions, each of them is called a strategy. So it could be a simple action, for example, doing nothing is also considered a decision, an action, or a complex plan of actions, like step by step, how to solve this term of trade, like hygienic, and then tariff, non-tariff measures, a full set of action. So usually the set of strategies open to player I, or what he or she can choose to do, is denoted as the capital S with an index I for player I. And within this set, a strategy chosen to play or to act by player I denoted as the small s, again with the index I for player I. Just introducing to you some notations so that you understand what's happening when they used more and more later. The last element of the game is the payoffs. So payoff is just simply the reward or the loss that caused by the strategy played by the player. So in economic setup, we just simply divide it as the level of utility, whatever utility represents, obtained by the player. And also in this setup, we maintain the main axioms of economic theories, in which rationally players prefer more payoff or more utility than less. Now, so the payoff is, because it's about utility, is denoted as U or 1. Sorry, U again. With the index 1 for player 1, for example, when he or she plays the strategy S1, and when the other player, the second player, let's say we have 2 players in this game, plays the strategy S2. On the other hand, the utility or the payoff of player 2 will be U2 when he or she plays S2 against the strategy S1 played by the other player. And these are the strategies, remember, adopted by both players, but in the same circumstances, in the same scenario. Not different one. Now, there is a very famous example of game theory, which is called the prisoner's dilemma, which is used very much for the introduction of game theory. Let's look at the setup of the situation first. So here's what happened. There are 2 suspects. They arrested for committing a crime. However, the district attorney does not have enough supportive evidence to conclude this crime. So she really eager to extract confession from the suspect, and she consequently make a deal to each of them separately. So the 2 suspects separated in separated place. They don't know the communication of the others with the district attorney or the police. No, they don't know what the other thinking or decision to make. However, they know which set up strategy they have and the other has. Okay. Here's the deal. So the district attorney said to each of these 2 suspects, now if you think on your companion was thinking means telling what the other did in a crime. So if you think, but your companion doesn't think on you, then you get a 1-year sentence, and your companion gets 4-year sentence. So stay in prison 4 years. Why? Because if you think, then she has the evidence for the crime that the other committed. But when the other doesn't think but stays silent, she doesn't have the evidence for this first suspect. So that's why who thinks will get less years in prison. Okay. On the other hand, if you both think on each other, then of course they have, or she has, the evidence for the crime from both suspects, and each of them will get a 3-year sentence, 3 years in prison. However, if neither of the suspects thinks, each will get tried for a lesser crime, so a smaller more minor crime, not the one that she interested to have evidence. And in this case, it will get a 2-year sentence for this lesser crime. No? And this is the strategic situation because what each suspect will get at the end, how many years in prison, does not only depend on his or her decision, but also depends on the other's decision, and their expected outcomes obviously not the same, right? They wanted to get a few years in prison as possible, and that involved having more years in prisons for the other party. So that's a strategic situation. The interests are not the same. Now let's think about which strategies each suspect or each player has. Now, from the description before, we know that each will have two possible strategies, either think or silent, nothing else, right? And when the two players play the game simultaneously, there will be 4 possible outcomes of the game. So the first will be the first one think, but the second one stay silent, right? The second scenario is the first one think and the second will also think. Both of them think. The third scenario is the first one stays silent, but the second one think. And the last strategy is both suspects stay silent, right? That's why it has 4 combinations of 4 scenarios. The payoff is the third element of the game that we have to take care, right? So the payoffs here depends on the strategy, and it could either represent as a decision tree or a matrix. To summarize the structure of the game. Normally, if it's presented in the form of a decision tree, then we call extensive form. If we put the payoff in the matrix, it's called normal form. We will see it in the next slide, both of these forms. Yeah. So because in the beginning, we already assume that payoffs in economic situations, usually the utility. But here, when we talk about the years in prison or the years sentence, that's something negative, right? You could never earn utility from stay in the prison. Of course, some, but in common sense, let's assume it's negative. So in order to avoid this confusion for the very first step of analyzing the game, we put it differently. So we express the payoff as the number of years of freedom over the next 4 years. Now, so in the worst case, when you get 4 years in prison because the other think on you, but you stay silent, right? Then your payoff is 0. So within the next 4 years, you spend none of the year outside. Now let's look at the extensive form first. So it's the decision tree. I somehow feel that it will be more intuitive to start with the decision tree than the matrix. So we look at it first now. So if you look at this decision tree, you see several nodes, like the big black dots over here. Each of them represents a decision point at which either of the player will make a move or play a strategy or decide what to do. So let's start with player one. He or she could either think or silent, right? So two possible actions. And corresponding to each of the actions, the other suspect or the other player will also have two possible actions. And each of the combination of actions of the two players will lead to a different combination of payoff for each of them. Now, so if both think, then they only have 1 year of freedom, 3 years in prison. Then if the first one think, but the second stays silent, then the first one will have 3 years of freedom, while the second one has to stay entire time in prison. And so the other way for silent, right? However, here it can be misleading with the decision tree that the first player moved first because his decision node started first to the left. We could think about it that way. Actually, it's another type of game that we will deal with next week. However, for now, because we said that it suspect that both of them were separated in separate rooms and dealt with the district attorney in private, right? So they kind of make the decision simultaneously. So in order to denote that setup, we have this dotted oval or circle over here. So the dotted circle indicates that the two players actually start at the same information set. So they make the decision simultaneously. The second player does not know what players want move and the other way around. So we need that dotted for simultaneous moving game. However, sometimes it will be more convenient to put the game into a matrix. Imagine you have many players and many strategy. It will be a lot of work to put that game on the decision tree, and probably it would also not very helpful for our intuition. So in such cases, the matrix or the normal form will be more practical to do. So how we do that is we put the payoff in the matrix because each player has two possible strategy. We have 4 combination, and here we have 4 cells. So 2 possible strategies of player 1 is written in the row of the matrix, and for suspect 2 is the column of the matrix. And 2 times 2 is 4, right? So 4 possible combination. And for each of this scenario, based on the description before, we could put the payoff for each player inside the cell. For example, if both things, then they get 3 years in prison. Consequently, the payoff is 1 for each. But if they both stay silent, then they only have to stay in prison for 2 years, and they have 2 years of freedom as payoff, right? Later, we will say how to solve for the game. But for now, we are done with the first task. The first task is to identify the elements of the game. We have the player, which are the suspects. We have the possible strategy with a think or silent for both party, and we also define their payoff and put to a simplified models, right?